What's going on, everybody? So this week we are going to start taking these exponential functions and looking at them in the context of word problems, or we're going to model with them is another more specific way to address that. So before we do that, though, we have to start kind of breaking things down and establishing those building blocks so that this all makes sense when we get a little more complex. But you'll see here two words that you're familiar with, the words growth and the words decay. Now, the word growth, everybody knows, it means that we are getting bigger. But you may not know that the word decay, it actually means that we're going to be getting smaller. So you'll hear it a lot in science, but we're going to talk about it here in math first. So when we talk about growth, which we're going to look at on this side over here, so I'll just write out so that we know that we're talking about growth over here. When we're looking at growth, we notice this table first. Okay, let's go to this table. You'll see that as my x values get bigger, my y values get bigger, okay? So along that x, you'll see we've got our standard, -2, -1, 0, 1, 2. And then our y values get larger and larger. They're doubling in this particular instance where we go 1, 2, 4, 8, 16. So that tells you that our graph is growing, that we're showing growth from our exponential function. Now the graph itself, obviously we've learned to read these graphs from left to right. And as you can see, when we move from left to right, that graph is clearly getting bigger, or that y value is getting higher. Therefore, we are growing. Okay, so now let's take a look over here. And the difference is with our table on the decay side. So let me write out the word decay so that we're all on the same page. So on our decay side, it's going to be the opposite, right? We've got ourselves with our x values getting bigger, but then our y values are going in the opposite direction. As our x values get bigger, our y values get smaller, right? And I realize that those are kind of counterintuitive arrows there, but you'll see exactly what I mean when we get over here to this graph, because once again, we read from left to right. And this time, as we go from left to right, that graph gets exponentially smaller on the y value. So that's the visual representation of growth and decay, but we need to look at these functions and see what is different. Okay, there's only one thing that's changed when we talk about growth and decay, and you guys have all come to learn what that is called. That is what we call our common factor. Our common factor for growth is always going to be a number greater than 1. Always going to be a number greater than 1. That tells us that we are growing. Now, you'll notice that my common factor for my decay is a fraction, or it's a part of a whole, which means that it is always going to be, my common factor will always be less than 1. Less than 1. Okay, so anytime we are decaying, you're going to see that that common factor is less than 1. Anytime we are growing, that common factor will be greater than 1. Okay, so now let's see how this works in context. All right, so the first example that we're going to talk about is some different words. Come on now. Let's see if it's going to allow me to go to that next slide here. Yep, perfect. Just going to take a moment because I am in my basement and my internet at home is spotty because I do not pay for premium. So now let's look at growth or decay here. We're going to talk about it in terms of word problems. And so like I mentioned, we have to be able to pull this out from the information given to us. All right, so Ant-Man, we all know this little guy. It was a great movie. Ant-Man and the Wasp might be even better, but Ant-Man is 5 inches tall. He triples in size every minute. Well, when you look at that, okay, we know that he started off at 5 inches, but then he triples in size. If he triples, does that mean that he's getting bigger, or does that mean that he's getting smaller? Because that word triples is the key here, and that should tell you anytime you're tripling anything, you are growing, right? If I've got $2 and I triple it and I've got $6, not only am I a happy customer, but I'm also growing my net worth. So now we want to ask ourselves, well, what is that common ratio? Well, you guys know this. It might not be written out in number form, but the word triple has only one number that is attached to it. Think baseball. When you hit a triple, you get to which base? Third base. So what is the common ratio in this case? That common ratio will be 3. So the word that tells you whether or not you're growing or decaying is also the word that's going to help determine by how much are you growing. So for instance, let's look at this second problem here where we talk about a bowl of popcorn. This bowl of popcorn on the table, let me backtrack. There's a bowl of popcorn on the table. Mrs. Ott eats half the popcorn every 2 minutes. Okay, so in this, I realized I wasn't specific. Are we talking about Mrs. Ott's cholesterol or are we talking about the popcorn? Well, we're going to talk about the actual bowl of popcorn. So if she's eating half of the popcorn, we know that there's going to be less and less popcorn in that bowl. So that word half tells us what's going on. She's eating half of that popcorn, which means that we are losing popcorn. So therefore, we are in fact decaying when it comes to the popcorn in the bowl. Well, what is the common ratio? Bing, bing, bing. It tells us right there that common ratio is 1/2 because we are cutting that bowl of popcorn in half every single 2-minute span. Okay, so it's that simple. You just got to look and pull out what you've already learned, right? Let's combine some English with some math and see where it takes us. In this case, triple means to go up by 3, and to eat half of something means that we're going to be cutting it in half. Now, this is where we get a little tricky. We got to talk about percent increase and percent decrease. Now, before I even go into any of this, stop reading. Before I even go into any of this, let's think about what we do when we talk about percent, right? There's a standard. Everybody talks about 100%. Well, that's where we start. That is our beginning point. All right. So I want to write that up here. 100% is our starting point when we talk about percent increase. So 100% is our starting point. And this will make sense in a moment. Is our starting point. I just told you to think English and math, and I realize I'm struggling with spelling. Somebody call Miss Matthews. I need some help. Our starting point. All right. So 100% is our starting point. And that is going to make sense here in just a moment because you'll see here how we need to use these other numbers that come at us to determine what our common ratio is. All right. So you bought a pair of Jordan 11s 10 years ago. We all know that Jordan 11s are one of the greatest shoes ever created. And so today, those shoes are worth 30% more than what you bought them for. 30% more than what you bought them for. So we need to know right now, okay, are we increasing the value of those shoes or are we decreasing the value? Well, if they're worth 30% more, that tells me that we're increasing, right? And once again, that means we're going to see growth. Now, the common ratio, this is where things get a little tricky. This is where we really need to pay attention to what's going on. Now, if I said that the common ratio was 30%, remember, that's what you're multiplying by over and over and over and over again, okay? If you multiply something by 30%, well, that's definitely going to get smaller and smaller and smaller every time. If you don't believe me, do it right now. Take 10 and multiply it by 0.3. And then multiply that by 0.3, and then multiply that by 0.3. You're going to notice that that number is getting smaller and smaller. So how do we take this 30% that we know is obviously important, right? It's in the problem. It's the only number in the problem other than our 10 years. How do we make sure that we are growing at 30%? Well, if you were paying attention to about, 2 minutes ago, what's our starting point? 100%. So we need to actually add that 30% to our 100%. And our common ratio is going to be 130%. But since we always write this as decimals, the common ratio will simply be 1.3. Okay? The common ratio will be 1.3. That's taking our 100% or our 1 and adding the 30% or our 0.3. Okay? So starting point's 100. Whatever you are growing by, you must add to 100. Now, conversely, converse, see what I did there? First we were talking Jordans, now we're talking New Balances, and no point in there where we're actually talking about Converse. But you will see this as my new dad life. I bought a pair of white New Balances 4 months ago, but now they've lost 40% of their value. They're no longer squeaky clean and perfectly white. So they've lost 40% of their value. Okay, so remember, we got this common ratio up here of 100 plus 30. Okay, that's how we got our 130%. Well, now let's take a look at this. If they've lost value, do we think that they are growing in value, or do you think that we're decaying in value? I'll give you about 2 seconds to make a determination on your own. Decaying. Okay, when we're losing value, we are decaying. Now, just like before, if you said, okay, well, 40% must be what their value, you're right in that you're going to get smaller and smaller numbers, but we can't say that it's 40% as our common ratio. We have, where is our starting point? 100% is our starting point. So just like up there, this time, up here we did 100 plus 30 because we were growing by 30. Down here, we have to do 100 minus 40 because we are decaying by 40%. We are losing 40%. Well, 100 minus 40 is going to be 60%. Now, we always write these as decimals, and so 60% as a decimal is 0.6. This is my common ratio of 0.6. Okay, it's that 100 minus 40. So these are the key terms that you need to understand: the growth and the decay, and then how percent increase and decrease begins at that 100%. If we don't get that piece, we're going to have a lot of miscalculations that we're not looking for. All right, go ahead, use this. Make sure that you feel comfortable with it, and then go ahead and get working on your assignment for the day.